We're going to solve some linear inequalities in one variable. Now we have an addition property for inequalities, same as the addition property for equations. The multiplication property for inequalities, though, is a little bit different. The first two examples will show what I mean. Here I want to solve this for x. I have 3x is less than 6. If this was an equation, I would simply multiply both sides by 1/3. Well, the multiplication property for inequalities says that it's okay to do that. And since the number that we introduced with multiplication is positive, that inequality stays pointing in the same direction that it did. Now, I'm going to do the same thing over here. I want to solve this for x. I see I have negative 2 times x, so I'll multiply both sides by its reciprocal, negative 1/2. So negative 1/2 times negative 2x, if I do that to the left side, I have to do it to the right side also. Negative 1/2 times 8. The multiplication property of inequalities says if you introduce a negative number with multiplication like this, you have to reverse the direction of the inequality. It was pointing to the right, now it needs to point to the left. That is the only difference between the multiplication property for equality and the multiplication property for inequalities. You can still multiply by any number you want. It's just that if that number happens to be negative, you need to reverse the direction of the inequality at the same time you multiply. Let's finish these problems. 1/3 times 3x is x. 1/3 times 6 is 2. My solution is all real numbers x such that x is less than 2. On the other side, negative 1/2 times negative 2x is x, less than negative 1/2 times 8, negative 4. So that's all real numbers that are less than negative 4. So there's a look at the multiplication property for inequalities. Let's try a more complicated equation. I have 2x minus 3 less than 9. Let's start by using the addition property to get rid of the negative 3. 2x minus 3 plus 3 is less than 9 plus 3. I can add the same number to both sides anytime I want. It won't change the solution to this inequality. Here I have 2x is less than 9 plus 3 is 12. Multiply both sides by 1/2 and I get x is less than 6. There's my solution. I want to go one step further here and graph that solution. I put in 0 for reference. 6 right here as the end point. I want to draw an open circle around 6 and graph all the numbers that are less than 6 on the number line. Now, if my inequality would have been less than or equal to, I would have colored in this end point. But since it's strictly less than, I leave the end point open. If it would have been greater than, the arrow would have pointed in the other direction. All I need is 0 for reference and my end point, and I can sketch that graph. Let's try one last problem. 2 times 5 minus 2x in parentheses less than or equal to negative 20. Let's multiply. 2 times 5 is 10 minus 2 times 2x is 4x less than or equal to negative 20. I'll add negative 10 to both sides and I have negative 4x less than or equal to negative 30 because negative 20 plus negative 10 is negative 30. I need to multiply both sides by the reciprocal of negative 4. That's negative 1/4. It's okay to do that anytime I want, as long as when I do that, I also reverse the direction of the inequality because I've introduced a negative number with multiplication. Do that to the left side, do it to the right side also. So here I have just x greater than or equal to, a negative times negative is positive, 30 divided by 4 is 15. No, it's not. It's going to be 30 over 4, which is 15 halves. So I'll put in 0 for reference. Over here is 15 halves. Draw a circle around the endpoint 15 halves. It's greater than or equal to, so I color it in. And since it's greater than or equal to, my arrow is going to go to the right. So there is the solution to this inequality right here. All real numbers x such that x is greater than or equal to 15 halves. So that's how we solve linear inequalities in algebra.